Okay, so we just did our learning about the elements worksheet there, and that was fun being able to use the periodic table of the elements and figuring things out. We're about to start Unit 2 on the elements, Lesson 6. Okay, so this is Lesson 6, Metals. Silver and gold have I none, silver and gold have I none, but what I have shall I give, in the name of Jesus Christ of Nazareth, get up and walk. What are the properties of metals? So my Roman numeral 1 shall be metals, M-E-T-A-L-S. And if you look at the periodic table of the elements, you will see that there are several metals. We've got alkali metals. Those are the ones on the far left. And we've got alkali earth metals. Those are the purple ones there. We've got transition metals, which are all these yellow ones. And then we've got poor metals, which are these light green ones. And then we've got metalloids. I wonder if they count as metals or not. They act somewhat like metals, but they're not actually metals, I don't think.
For a science experiment this year, can we collect as much of the periodic table of the elements as we can without creating a fusion?
We'll see. I'm not promising anything. Words to know: malleable, ductile, reactive, metalloid. Oh, goody, we're going to look at those. And semiconductor. Challenge words: noble metals, poor metals, and reactivity series. That sounds cool. What do you think of when you hear that something is made of metal? Do you think of something hard, heavy, strong, and shiny? That'd be a pretty good description of most metals. Do you think of cars, washing machines, silverware, or coins? Those are just a few of the many uses for metal. 3/4 of all elements on Earth are metals. Most are strong and heavy. However, a few pure metals are weak or soft. The majority of metals have the following 6 characteristics. So metals, let's see. I'm going to do my number 1 as characteristics. 1, characteristics. And then I'm going to bullet point them. Some of the characteristics of metals are silvery luster on the surface. Silvery luster, comma, surface. Solid at room temperature, except for mercury, which is liquid. Second characteristic, second bullet point, solid at symbol, room temp. In parentheses, I'm going to put not mercury. Elijah, take all the notes that I'm taking. Third, it is malleable. That is M-A-L-L-E-A-B-L-E. That is, it can be hammered into a shape. Malleable equals can be hammered, yield shape. 4, the fourth bullet point will be ductile. D-U-C-T-I-L-E. That means it can be drawn into a wire. Drawn, yield, wire. Number 5, fifth bullet point, it is a good conductor of electricity. I'm going to put a check mark to mean good. C-O-N-D-U-C-T-O-R dash electricity. And finally, tends to be very reactive. Greater than sign, reactive, R-E-A-C-T-I-V-E, which means equals easily combines with other elements. Check mark to say good. Combines with symbol other elements. Most metals have 1 to 3 valence electrons. They easily give up their electrons, which is why they are reactive with many other elements. Down here underneath, very reactive, I'm going to say usually USU 1, 2, 3, V, or 1-3, val elect, usually 1 to 3 valence electrons equals give up electrons. So since they usually have 1 to 3 valence electrons, they go, I didn't really want those anyway. Here, this other element, you can have this 1, you can have these 2, you can have these 3 to fill up your last row that currently has 7 or 6 or 5, because that last row is probably going to want to try to get up to 8.
Like a cake.
Yes. This is also why metals are good conductors of electricity. Because of their unique characteristics, metals are used in a variety of ways. My number 2 here is going to be uses. Their strength and malleability allow them to be used for making cars and trucks. Uses. Vehicles, V-E-H-I-C-L-E-S. Bridges, B-R-I-D-G-E-S. Appliances, I'm just going to say machines, M-A-C-H-I-N-E-S. Aluminum siding and soda pop cans, comma, cans, comma, etc. Uses: vehicles, bridges, machines, cans, etc. Metal's conductivity of electricity is why metal is used for electrical wiring in nearly every house and building in America. Underneath uses, I'm going to say especially electrical wiring. Elijah, take notes. If I have to tell you that again, that will be a tally. As you go across the periodic table from left to right, the elements become less metallic. My number 3 will be periodic table, and I'm going to draw I'm going to leave a space and draw a little representation of the periodic table. And I'm going to say on the left side, it is more metal metallic, metallic. 2 on the right-hand side, less metallic. This means that as you go from left to right, they become less malleable, less ductile, less conductive. The dividing line between the metals and the nonmetals is the diagonal line of elements shaded dark green on the periodic table. These 7 elements are called metalloids. My number 4 will be metalloids. metalloids. Metalloids divide metals from FR non-M. The metalloids divide the metals from the non-metals. The metalloids are called semiconductors. Metalloids, I'm going to draw a little arrow underneath that and say AKA, that means also known as semiconductors. semiconductors. The metalloids are called semiconductors because they conduct electricity only under certain circumstances. AKA semiconductors because B/C only conduct with right circumstances. This is an important characteristic for the technological world. Semiconductors are used to provide low power, yet high speed in electronic devices used in many products such as computers, digital watches, and cell phones. So these, I'm going to draw another arrow under here, metalloids, aka semiconductors, are used in the symbol electronics to yield less than power and greater than speed. Low power, high speed. Fun fact, manganese is the only metal that is not silvery, thank you, ductile or malleable, which may make it seem like a non-metal. However, manganese acts like a metal when it is alloyed or added to other metals, which is very interesting.
It's a transition metal. It's number 25. Mn.
Cool, that is a transition metal.
My favorite element is molybdenum.
Well, that's a fun name. All right, taking a look at reactive metals. Metals can be grouped according to how reactive they are. Based on what you have learned so far, which metals would you expect to be the most reactive? Take a look at your periodic table. Which ones would be most reactive, do you think?
The ones with more. Actually, no, transition metals are
The
solid.
one on
I think non-metals and noble gases.
the one on the far left.
The one on the far left is going to be the most reactive. If you remember in the periodic element song, which we can watch again, it specifically says that, I don't remember what the terms were, but noble gases are non-reactive, but I don't remember what they called. column 7 and column 1, those ones react a lot together. The column 7 is almost full, like its outer layer is almost full. It has 7 electrons, and it's going, I just need one more in order to finish this. Please let me finish my collection. And all of the ones in column 1A have 1 valence electron. So they're going, this one is farthest away from my nucleus. I might not need that one. You can have it. And so the ones in column 7 will grab the 1 valence electron from column 1. Those ones will react very highly together. Those ones are volatile together. You may have heard of hydrogen chloride. That has to do with hydrogen in column 1 and chlorine in column 7 joining together. Also, you've heard of sodium chloride. Eliana, focus. Sodium chloride. You've heard of, that's table salt. Sodium is in column 1. Chlorine is in column 7. I wonder if there's such a thing as potassium iodide. It wouldn't surprise me. I wonder what it does. But you can bet that there will be things that are reacting from column 1 with column 7. But column 7 is nonmetals. Column 1 is metals. We don't usually think of hydrogen as a metal, do we?
No. I think of it as a gas.
Okay, so reactive metals. Metals can be grouped according to how reactive they are. Based on what you've learned so far, which metals would you expect to be the most reactive? If you said the metals in the first column, you would be correct. The alkali metals are the most reactive metals. My number 5,
That's what it was, alkali.
that's it. My number 5 is going to be reactive metals, and I'm gonna draw another diagram of a periodic table. Looks kind of like a castle or the Adventure Time mask. And I'm gonna say on this side, Al, alkali, 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 M for metals, are most R for reactive. Alkali metals on the left are the most reactive. Did I do that right? Yes. The alkali metals are the most reactive metals. Sodium and potassium are both very reactive with air and water as well as other metals. Therefore, they must be stored in oil to keep them from reacting with the air. Wow.
What is?
Sodium and potassium are both very reactive with air and water and must be stored in oil to keep them from reacting. The alkali earth metals, those elements in column 2A, are also highly reactive, but not as reactive as the alkali metals. If they're in column 2A, how many valence electrons do those ones have?
2.
2. So they're going, we could hold on to these 2, or we could let you have them. And the ones that have 6 valence electrons are going, well, I do still need 2 in order to complete my collection. So yeah, I'd kind of like to have those. I'm going to put a bullet point under reactive metals. I'm going to say whoops, I need to try again. Alkali M equals most, I already said this, so I'm doing it again. Most are reactive, and under that, I'm putting another arrow to say alkali dash earth metals equal reactive, but in parentheses, not as much. The alkali earth metals, those elements in column 2, are also highly reactive, but not as reactive as the alkali metals. Because these metals react easily with other metals, they readily form compounds. Calcium, one of the alkali earth metals, is found in large amounts in the crust of the earth in the form of calcite, which is the main ingredient in limestone. Calcium is also found in seashells in the form of calcium carbonate. Alkali metals and alkali earth metals are seldom found in their pure form because they're so reactive. I'm going to put another arrow. I'm going to kind of make a little brackety thingy to join alkali and alkali earth together and draw a little arrow from there to say not symbol, usually USU, found, comma, pure form because B/C are reactive. They're going to be reacting with air and water and other metals and whatnot in order to become joined with other things. All the metals in the center of the periodic table are called transition metals. Transition metals are what you might consider more typical metals. These are the metals that are used in many of the applications we mentioned earlier in this lesson, like cars and bridges and whatnot. You wouldn't want your bridge to suddenly react with the water. A few of the transition metals, those to the far right of the group, including gold, silver, copper, palladium, and platinum, are often grouped together as noble metals. Do you remember which column was called the noble gases?
The far right.
The far right, that's right. They don't react. The noble gases are the elements in the far right column. They are the gases that do not easily react with other elements. Similarly, the noble metals do not react easily with other metals and are often found in their pure form in the crust of the earth. My number 6 is going to be noble M, noble metals, equal not symbol R, not reactive, yields found in symbol pure form earth symbol crust. So these would be things like silver, gold, copper, platinum, finally, the metals to the right of the transition metals, including aluminum, gallium, indium, tin, antimony, lead, and bismuth, are called the poor metals. My number 7 will be poor, M, poor metals. These metals are colored light green on the periodic table. that you guys all have. These metals are generally more reactive than the transition metals, but less reactive than the alkali and alkali earth metals. Poor metals are usually very soft, usually not very useful by themselves. Poor metals, in parentheses, I'm going to write, no worries, aluminum, A-L-U-M-I-N-U-M, aluminum, comma, tin, comma, lead, comma, etc. Poor metals equal more are reactive than transition metals, which are in the middle, but less reactive than the alkali and alkali earth metals. And then some of their characteristics I'm going to put underneath there. Poor metals, characteristics, greater than sign, soft. Comma, not symbol, useful alone. However, they are good when, nope, good, check mark, mixed with symbol other metals. In order to give people a good idea of how reactive various metals are, scientists have developed the reactivity series, which lists a selected group of metals from most reactive to least reactive. I've got a list right here. It starts with potassium, ends with platinum. Most reactive, platinum, sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead, copper, silver, gold, platinum. Most to least. This list helps people know what to expect from several common metals when they come in contact with various substances. The most reactive metals will react with water, acids, oxygen, and many other substances. Okay.
Wait, is hydrogen metal?
No, it's in its own category. My number 8 is going to be reactivity series. Reactivity series equals what to expect. Thank you. When they come in contact with various substances. What to expect. Contact with. For example, what to expect when they come in contact with H2O, comma, acids, comma, oxygen or O2, comma, etc. These metals are at the top of the list and are found in columns 1A and 2A. Metals that react with acids but do not react with water are next on the list. These metals are found in columns 2A, 3A, and 4A. Many of the transition metals, 1B through 7B, react only with oxygen and are near the bottom of the list. Finally, metals that do not easily react with anything, the noble materials, are at the bottom of the list. Cool. Okay, that is science. Your notes should look something like this. Good job.